Module 7, GUV lamp technologies. In this section, we explore artificial germicidal lights, definition of photobiology, optimal germicidal wavelength, and GUV lamp technologies. Germicidal ultraviolet can be created artificially, and we want to then create certain wavelengths that are most beneficial to inactivate bacteria and viruses. So here on this image, it is an excerpt from the electromagnetic spectrum, and it shows the UVC energy, the ultraviolet light, in the region ranging from 207 to 280 nanometers wavelengths. So we know that this region is known for its germicidal property and inactivates bacteria and viruses. So what can be done is GUV lamp technologies can create these different germicidal wavelengths, and depending on the GUV lamp technology, specific wavelengths can then be generated. Before exploring the lamp technologies, let's have a look at photobiology and its effect on living organisms. But first, what is photobiology? It is the study of the effects of light on living organisms. So photobiology is broadly defined to include all biological phenomena involving non-ionizing radiation. It is recognized that photobiological responses are the result of chemical and/or physical changes induced in biological systems by non-ionizing radiation. So germicidal ultraviolet has a photobiological effect on bacteria and viruses. There is an optimal germicidal wavelength, and the most effective photobiological response is at around 265 nanometers. So the germicidal action spectrum defines relative effectiveness of differing wavelengths in producing a photobiological response. Bacteria and viruses differ in how they respond to germicidal ultraviolet, but most will be inactivated when exposed to enough GUV energy. So artificial UVC lamps can generate different wavelengths, for example, 222 nanometers, 254 nanometers, 265 nanometers, where they're all effective in inactivating bacteria and viruses. Artificial GUV lamps can act as a germicide and create this photobiological response that was just discussed. So the most common types of GUV lamps used for upper room and whole room GUV fixtures are low pressure mercury lamps. They generate 253.7 nanometers, commonly referred to as 254 nanometers. Excimer lamps, which generate 222 nanometers, often referred to as krypton chloride lamps. And light-emitting diodes, LEDs, that can generate various wavelengths, but mostly the 265 nanometers is used for germicidal applications as LED. Back to the excerpt of our electromagnetic spectrum showing the different lamp technologies under the UVC energy spectrum. On the left, with the lower energy, we see the krypton chloride or excimer lamps at 222 nanometers, followed by low pressure mercury lamps at 254 nanometers rounded, and LEDs around 265 nanometers. Let's look at low pressure mercury lamps. They generate UVC at 253.7 nanometers, again often rounded to 254 nanometers. They are available in many different lengths and shapes. They're the most efficient method to generate germicidal ultraviolet. And electrically, they're the same as a fluorescent lamp. They're available in various sizes, wattages, and they are equipped with ballasts. They are constructed with a special kind of glass that allows transmission of approximately 80% of the 253.7 nanometer energy, which is generated by mercury discharge. Excimer lamps are very small compared to the low-pressure mercury lamps. They use rare gas halogen excimers, mostly krypton chloride for commercial applications, and they produce most of their emissions between 200 to 230 nanometers. Most of the emission is at 222 nanometers. Their advantage is the effect on human skin and eyes is much reduced as compared to 253.7 nanometer mercury emissions. Their disadvantage, they have the potential of ozone production. Light-emitting diodes, in comparison, are very small in size, and often many are used in 1 GUV luminaire. Typically, they have a peak wavelength emission between 260 to 280 nanometers when used for most germicidal applications. They can be designed for germicidal output around the peak efficiency of the standard germicidal response function, which is around 265 nanometers. They're highly customizable, but their specific spectral distribution, peak wavelength, and performance characteristics can differ widely across manufacturers. These images show examples of various upper room and whole room GUV lamp technology fixtures. On the left, we see the 254 nanometer fixtures, which are the low pressure mercury lamp type of fixtures. In the middle, we see the krypton chloride fixtures, also known as excimers. And on the right side, we see images of LED fixtures. And you can see that they vary in size and they have, again, depending on the lamp they contain, they have different housings. There are many different installation options for upper room and whole room GUV fixtures. These images show various mounting mechanisms, including wall mounting, pendant mounts, ceiling mounts, and tripods. Let's review the key points. GUV lamp technologies can create different germicidal wavelengths. Photobiology is the study of the effects of light on living organisms, which can result in chemical and/or physical changes in viruses and bacteria. The germicidal action spectrum defines the photobiological response of the different wavelengths on bacteria and viruses. There are 3 lamp types used for upper room and whole room GUV applications: low pressure mercury lamps, krypton chloride lamps, and light-emitting diodes.